Okay, so here we're going to look at chapter 16, which deals with polygons, and we're going to review some kind of definitions and vocabulary. So chapter 16 concepts here are review of polygon vocabulary, organized shapes, triangles and quadrilaterals. Then we'll focus on some problem solving and then issues with some learners. So this is covering 16.1, which will deal with a review of polygon vocabulary. So here we have a formal definition of a polygon, and there's really three components to it. That it's made up of line segments that are joined and not crossing to reuse any of the endpoints here. And so we're going to look at these images on why they are not polygons. So the first one here is not closed. So that's one of the first characteristics of a polygon. We see the second image here, that it's not linear. So that's not a line segment. We want to make sure that we have a line. And then of course here we see that there's an intersection, right? So there's kind of that reusing of those endpoints. So no crossing of endpoints there. And it should be fairly obvious why these other two are not polygons as well, as they have more than one of these conflictions here. So some vocabulary, we have a polygon, and then we have what's called the polygon region. And so that polygon region refers to what is inside. So the inside region there. And so think of it as if we're coloring inside the line. So that's what's called the polygon region. And a diagonal of a polygon would be any line that connects the vertices. So the vertices are those endpoints where two line segments meet. Equilar polygon here, that means that all angles have the same size. And equilateral polygon means that it has all the same lengths. And then we have a regular polygon, which means both are the same there. So we could see that a square has equal angles and equal lengths. A rectangle is not an example of that, although it has the same angles. It does not have the same length of sides. And here we see the rhombus here. Although we don't know what the angles are, we see one that is obtuse and one is acute, so we know they're not the same, even though the line segments are the same. So let's think about these. Which ones appear to be regular polygons? So a triangle there, all three sides are the same length, and interior angles seem about the same there. We're not measuring these, but we're just kind of giving an estimate here. A square as well, and then kind of a diamond, which is just a square right rotated there. And then here we see a pentagon, right? So 5 sides are going to be interior there, the same. And then a hexagon as well. So those are all regular. And we could extend this out to shapes with more sides. So a bit of vocabulary, heptagons, octagons, nonagons, and then decagons as well. And we can see those are going to be the regular ones. That heptagon, a little strange looking there, but close enough. And then some review for angles of triangles. Acute triangles means that it measures less than 90. Right, so we see in here that the angles, all of them are less than 90 degrees there. A right triangle means that one of them is going to be 90 degrees, so we could see an example with those two triangles. And then we have an obtuse triangle. That means one of the sides is going to be larger than 90 degrees. Scalene triangle means that that all three sides are different. So we could see that from these two triangles there. And typically if the angles are different, then the sides are going to be different as well. And then an isosceles means that at least two sides are the same. So having two sides there, and we could see that two of the angles will also be the same. That second one there is also considered an equilateral with all three sides. So that's an isosceles and an equilateral. So there's a hierarchy of shapes over some could be subgroups of others. And we'll look at that more in the future sections, 16.2, I think, or 16.3, where we'll look at kind of organizing of shapes. And so just some vocabulary review. Here we have squares, rhombus, rectangles. So all quadrilaterals, but different types here. Parallelograms, we have kites, we have trapezoids. And then, again, no special names here of these quadrilaterals, so just some irregular shapes there. And so we could see subsets of these where we have a kite here, right, which is also a square. So you could see subgroups of these here. And we'll look at more hierarchies of these afterwards. Some more vocabulary. Points, when we talk about a point, we denote just kind of a dot there, and we typically label them with capital letters. A line segment connects two points, right, or would be considered two endpoints. A ray has one endpoint and it goes on in the other direction, so we see the ray CD here, so going on in one direction. And then we denote polygons where we label the vertices. So polygon FGHI would be denoted, and that's indicating that it's closed, right? We're talking line segments. Right angles. A right angle means it measures 90 degrees. Acute angles means that the measure is going to be less than 90 degrees. Obtuse angles indicate that it is greater than 90 degrees, and then a straight angle indicates that we have 180 degrees. Some more definitions here of adjunct angles means that they're just two angles that are next to each other, so they will share the same vertices. Supplementary means that the angles sum up to 180 degrees. And complementary means that they sum up to 90 degrees. And an exterior angle of a polygon is, here we have the actual polygon, and so that angle on the outskirts there, that's outside of the polygon, and an interior angle will be the angle inside in the actual polygon region. And so takeaway from this section is dealing with polygons. Again, just vocabulary there, simplifying these. And then there was an observation here where we noticed the sum of angles of an n-gon appears to be n minus 2 times 180 degrees. And there's an exercise that will further explore this.